Welcome to the podcast of Wageningen Alternative Protein Project, where people talk about their work in protein transition. I am Shan, a master's student in food technology, and I will be your host today. Our guest today is Nynke Coleman, who is doing a PhD project in Wageningen University. Hello, Nynke. We're so excited to have you here in the podcast of Wageningen Alternative Protein Project. First of all, can you tell us a little bit about yourself?
Yes, so I'm Nynke and I'm doing a PhD project about the extrusion of meat analogues at the Food Process Engineering group in the food structuring department. I actually just started this PhD only 2.5 months ago, so I'm still a bit fresh. And before this I studied food technology, both the bachelor and master here in Wageningen. And then I also did my bachelor and master thesis at the FVE group, so I've already been around for a while here. And during my thesis time, I really enjoyed it, and that's why I continued.
Wow, you have a long history with Wageningen and food science. What is your motivation for this project in particular?
I've always had a big motivation to do food technology, and an aspect that I always found very interesting is making the food system more sustainable. And I'm working on plant protein and meat analogues is for me a great opportunity to contribute to that. From my point of view, meat analogues might help people to consume less animal protein, especially for people that want to change their diet but are not hardcore vegan. So they can easily replace the meat in their diet with the meat analogues. So it would be nice if a meat analog could contribute there. And I'd like to contribute to making those meat analogues taste very good, because only then they have the chance to achieve that goal. And that was why I was very excited about this PhD project.
Well, that's nice. A lot of people would be interested to know more about your project, which is understanding structure formation and extrusion for meat analog application.
Yes, that's right.
I also think it deserves to be known by more people, especially those who already have an interest in the field of alternative protein. So could you explain it to us in a few sentences?
Well, actually, extrusion has already been used now by the industry to produce meat analogues. But still there's relatively little knowledge about the physical and chemical processes taking place during the process. So we want to learn more about that and learn about the effect of processing on the structure of meat analogues. And that might also allow us to use alternative protein sources.
I also know that extrusion is actually a pretty old technology. In the last century, it was already very broadly used. But yeah, it is still right now still not very well defined, and a lot of it is actually based on empirical data from what I know. And what do you think it's making it so difficult to understand this process?
I think it's mainly that first of all, you cannot look inside the extruder. That's making it difficult because it's under pressure and it's at high temperatures. So if you would open it during the process, you would change the processing conditions. And then there's also a lot of parameters which you could change, and these parameters also influence each other. So if you change the screw speed, you do not only change the mechanical deformation of the material in the extruder, but also the temperature because of friction. So because of all these interrelations between the different parameters, I think it's making it difficult to get the whole picture.
Also, is it that also because the flow pattern is complicated in the extruder?
Yes, I think so.
Yeah, difficult to interpret. Then can you share with us about some obstacles in research in this field?
Yes, of course, in general for meat analogues, you don't only have the structure that needs to be right, but also flavor components you don't want to have, possible off-taste of the plant ingredient, for example. And people want to have the same color and even bleeding sometimes of a burger, or what kind of meat analog you are producing.
Yep.
And then you will need, of course, need to get the nutritional value right, and you want to use sustainably produced ingredients. So all these factors should be looked into, and I guess that's the major challenge, getting everything right in one go.
That makes sense. Then what do you think are the expertise and skill set that's required in this project?
I think for any research project, you need to be curious about your topic, and you have to need to be perseverant. And more specific technical knowledge that you would need for this project, I think rheology is quite important. So how the material responds to shear. I think that kind of knowledge is very important during my project. And of course you will also need to know about biopolymers. So I guess that are the main things you need to know for this project.
Then what is your view of alternative protein and its potential future development? Like, do you have a specific idea of which protein or what kind of technology will have the most potential of developing into this, let's say, perfect alternative protein product?
No, to be honest, I wouldn't dare to pinpoint one specific protein source that will be the perfect fit. I think there are still a lot of options that need to be explored, but really to say which ingredient is the most promising or which technology, you cannot say that before research is done. I think it's also, how do I say that? I'm not a plant scientist, so I don't know what's possible there.
I guess a lot more interdisciplinary efforts needs to be made in this research field. Do you have like personal hobbies related to alternative protein or the transitional protein, or have doing this project changed any like habit for you in your personal life?
I think while learning more about sustainable food production, my meat consumption decreased a bit. I've started to eat less meat. I also like to cook vegetarian meals, also meat-containing meals, because I'm not a complete vegetarian yet. Other hobbies related to plant proteins, not really, mainly cooking. I'm not really into growing my own soy or something like that.
Then do you also often buy the plant-based meat product from the supermarket and cook it yourself?
That's actually since I started this project, I've been doing that a bit more, just to experience what they look like. I think like once or twice a week.
Yeah, that's also what I'm doing. Like after I started this study, because only by eating it can you actually tell like how is it like. And anything you want to tell the fellow students in Wageningen University who are interested in this field?
If you are interested in this field, you have already come to the right place by listening to this kind of interviews, of course. And if you are in food technology or biotechnology, you can of course look at the thesis topics at FPE always. So there are a lot of topics there, not only my project, but also from other PhD students, where you could maybe collaborate.
So like for your project, it's also possible to do a master thesis or bachelor thesis?
Yes, that's possible. You just need to follow the normal allocation procedure for that.
That's good to know. Thank you very much for being with us today. And I learned a lot from talking to you about your project. And I'm pretty sure the audience is also going to be very interested in this topic. Thank you very much.
Thank you for inviting me.
We're looking forward to the opportunities in the future to talk to you again.
Thank you.
Thank you for listening. If you have enjoyed it and would like to hear more interesting interviews about alternative protein, subscribe and follow our Facebook page of the Wageningen Alternative Protein Project. Thanks again, and we will see you in the next episode.